All right, here we are. Day 16 of your home learning. A very short video again today for those of you who are listening, which, I've seen the views. It's not many of you, but, they're short, so you should be able to listen to a few minutes. Anyway, we're talking about linear regression this week, so an important concept to remember is what a residual is. Hopefully, you all know that it's y minus y hat, or the actual y value minus the predicted y value. I said the way I remember that is that this is an AP class, so that's why you do A minus P. Now, here, I know they're a little blurry, but here we have some residual plots. Hopefully, you see that one of them looks appropriate, meaning one of them is telling me that my regression line is a good fit for my data. And the other two, we could probably do a better job. Okay? So, quick review in case anybody forgot. If I have an original scatter plot, I'll even make it negative. Here are all my points. And if I fit an appropriate line to it, maybe I'll add a couple more dots down here. That means I should have some positive residuals, some negative residuals, and it should look similar to this residual plot above. A random scattering. A bunch positive, a bunch negative. Okay? Now, the next most common one you'll probably see is this third one where, yay, good fit for this one. Woo! The other two, not the best. The reason this third one is not the best means because it has a bunch of negative residuals first, then a bunch of positive, then a bunch of negative again. Yeah, there's this one, but in general, the trend looks like this. There's a pattern, a curve to the residuals, which means my original one maybe looked something like this, where if you fit a line, it would have negative residuals at first, then positive residuals, then negative residuals again. Yeah, there might be some that don't quite fit, right? And clearly, this line does not fit this data well. I mean, you want to transform it or you want to fit a curve to it. So that's why you want to see a totally scattered residual plot. This middle one, they don't address too much in AP statistics, but really what it means is you have some data start out close together and start to fan out. So maybe the line fit the data well down here, but then, there's got to be something better we can do. So once again, we could transform this data to reduce the variability out here, or at least you want to make a note that there's more variability as the values increase. But really, the important thing to keep in mind is we have good residual plots just mean that whatever line it has been fit is fitting the data well. And then we have these two residual plots where we could be doing a lot better. Okay? That's it.